You ever stop and wonder, how does all this AI stuff actually work? Well, today we're going to pull back the curtain. Turns out there's a simple 3-step blueprint that powers pretty much every AI project out there. Let's dive in. Seriously, just think about it for a second. Your smart speaker. You say Alexa or Hey Google, and somehow it just knows. Out of all the other sounds, the TV, people talking, how does it pick out that one single name? I mean, it really does feel like magic, right? But what if I told you the process behind it is actually surprisingly simple? Okay, so at the very core of all this is a super simple idea called A to B mapping. That's it. The main job of most AI is just to learn how to get from a specific input, let's call it A, to a desired output, which we'll call B. And honestly, that's the big secret. Whether we're talking about an AI recognizing your voice or driving a car, the goal is always the same. Build a rock-solid map that gets you from A to B.
So the big question is, how do you even begin to build that map? Well, it almost always comes down to this really straightforward 3-step blueprint. Step 1, collect a ton of data. Step 2, train the model. And step 3, deploy it and keep it updated. Yep, that's pretty much it. So let's break down exactly what that workflow looks like.
All right, first up, collecting data. I mean, it makes sense, right? You can't teach a machine, well, anything, if you don't give it something to learn from. This is the absolute foundation. It's like gathering all the raw ingredients before you can even think about cooking.
And this really shows that A to B mapping in action. Let's take the smart speaker again. The input, A, is just a short audio clip. The output, B, is super simple. It's either yes or no. Did that audio clip contain the word Alexa? So to make that work, you need, well, thousands and thousands of recordings of people saying Alexa. And, just as important, tons of recordings of them saying other words so it learns what not to listen for. Now, for a self-driving car, it's the same idea, just different data. The input A is an image from its camera. The output B, the exact location of all the other cars in that picture. This means you need a huge data set of road images where actual humans have gone through and painstakingly drawn boxes around every single car.
Okay, so you've got all your data. Now it's time for step 2, training the model. And honestly, this is where it starts to feel a little bit like magic. You basically take all that A and B data you collected and feed it into a learning algorithm. Its one and only job is to just figure it out, to find the hidden patterns that connect your inputs to your outputs. But here's a little reality check that every single AI developer knows in their bones. The first try, it never works. Or almost never anyway. You can't just dump the data in one time and expect to get a perfect AI model out the other side. Nope. Building AI is all about trying, failing, and refining. Actually, there's a specific phrase for this whole process. In the AI world, they call it iterating many times. And what does that mean? Well, it means they train the model, they test how well it does, they see where it's messing up, and then they tweak something. Maybe they add more data. Maybe they change the algorithm a little bit. And then they train it all over again. They just keep repeating that cycle over and over and over until the model finally gets good enough.
And this is a perfect example of what that looks like. You know, an early version of a self-driving car model might look at a blurry shape and go, yep, that's a car, when it's actually a fire hydrant. But after iterating, after being shown thousands more examples, and basically being told, no, that's wrong, again and again, it eventually learns. It starts to see the subtle differences and can finally, correctly identify the actual car.
All right, so you've collected your data, you've iterated and iterated until your model is looking pretty sharp in the lab. So now what? Well, now it's time for the big one. Step 3, you deploy it. This is where you take that AI software and you actually put it into a real product, into the smart speaker, into the car, and you ship it out to real people. But here's the thing, the work isn't over, not by a long shot. In a lot of ways, it's really just beginning. Because the real world, it is so much messier and more unpredictable than any clean data set you can create in a lab. You are guaranteed to run into new challenges you never even thought of. So for example, imagine your smart speaker was trained almost entirely on American English accents. The moment you deploy it in the UK, you suddenly realize it has a really hard time understanding when someone with a British accent says Alexa. Or think about the self-driving car. It's been trained on millions of pictures of cars, trucks, and buses, but then one day it sees a golf cart on the road for the very first time. What does it do? This is exactly where the process becomes a loop. You have to grab this new data, the audio of the British accent, the images of the golf cart, and you have to feed it right back into the system to constantly update and improve your model. So as we start to wrap this up,
The really important thing to remember is that this isn't just for smart speakers or self-driving cars. At the end of the day, this three-step process is a truly universal workflow. It's the blueprint for basically all modern AI.
So let's just run through it one last time really quick. Step 1, collect your data, your inputs A and your desired outputs B. Step 2, train that model, iterate, until that A to B mapping is really solid. And finally, step 3, deploy your model out into the wild and build that feedback loop to keep making it smarter with new real-world data.
So if there's one thing you take away from this, it should be this. What seems like some kind of impossible magic is really just driven by a logical and, surprisingly simple engine. This whole iterative cycle, collect, train, and update, that's what's powering everything. From that little device sitting in your kitchen all the way to the most advanced artificial intelligence on the entire planet.
And that kind of leaves us with one final big question to think about. If pretty much every AI team out there is using this exact same fundamental blueprint, what is it that separates a good AI project from a great one? The kind that really changes the world. Is it just having more data? Is it a slightly better algorithm? Or is it something else entirely? Definitely something to chew on. Thanks so much for tuning in.